Hi everyone. Thank you for making it to today's tutorial, and I hope you have been enjoying your day so far, and you still have energy for the last one now. So today we'll be speaking about the project I have worked on around customer reviews and two approaches which I have used, topic modeling and HuggingFace SetFit method. A bit about me. So I'm a data scientist working at Aon Next, an energy company in London. I'm also a certified AWS ML practitioner, and I serve as a subject matter expert. And as you note, I have contributed to the new certifications that AWS announced this week, the AI practitioner certification and the AWS machine learning engineer certification. So if any of you has any questions about these certifications, please come to me in these 2 days, and I'm happy to support and answer any related questions for these about them. Latest data science products I have been working on, ranging between generative AI called tagging, marketing propensity modeling, customer reviews classification, which we're going to talk about today, demand and supply forecasting, recommender systems, and customer lifetime value. I also have a master's degree from UCL, and my hobbies are tag rugby and hiking. The agenda of today's tutorials will be as follows. We're going to start talking about text analytics and customer experience from the broader perspective. Then we're going to cover the classic topic modeling, and including like text processing, feature engineering, and we're going to cover in particular the LD algorithm. So we're going to cover it from theoretical perspective, and we're going to have hands-on application to apply this unsupervised topic modeling approach. After we finish this part, we're going to move to the HuggingFace SetFit Few-Shot Learning method. We're going to explain it from theoretical perspective, and also we're going to have hands-on application to fine-tune a sentence transformer from HuggingFace and to generate model inference on customers' reviews data. And at the end, we're going to keep some time for wrap-up and Q&A from the audience. To start with, I would like to hear your thoughts on the topic. Think of it as a small icebreaker. So if I could ask you to join Slido. I tested before coming, so I hope it's going to work, no surprises. But I would like to hear your thoughts on the techniques and tools that you have used or been exposed to for analyzing customer reviews data. Nice. So we have 3 participants already giving input. Yeah, I think so. Nice. So, yeah, as we see, there are like broad tools and methodologies that can be used for analyzing customer reviews, ranging from LDA or word cloud, which is for visualizing topics, which we're going to talk about today. Sentiment analysis is another tool to detect the customer sentiment, whether it's positive, negative, or neutral. GenAI is the new booming tool using LLMs, whether with prompt engineering or few-shot learning, also like to generate topics about the reviews, clustering, BERT, transformer, of course, Roberta, and I think the list goes on and on. Name entity recognition is also another tool which helps us to detect some characteristics such as organization name, product name, location, or monetary value from the reviews. I used Herring. I haven't heard of that. Okay, nice. So yeah, I think almost like everyone have heard or like been exposed to one of the text analytics tools to classify or analyze customer reviews. I hope in today's tutorial we're gonna go in depth on topic modeling and SetFit HuggingFace method. Nice. The second question, which I also hope to get your input on is, what do you think will be, if you're working in a company, whether like in the data team, marketing team, finance team, whatever, what do you think will be the business impact of us having a tool which analyze and classify customer reviews? Nice. So yep, definitely to scale customer review analysis, of course, we can have like automated process rather than doing it manually or reading reviews manually. So we could have an automated process to do this for us. We could increase user satisfaction, customer satisfaction, keep the customer for us with us, because we are making sure that we are hearing about their thoughts and feedback. Predict what needs to be corrected or improved, whether through knowing what we could offer the customer for cross-sell or upsell. Follow the trends to see like if we have like a topic or like area of improvement that we as a business we have to work on in order to make the customers more happy. Nice. Yep, I think it's like a very, very, very comprehensive list. From bugs and product problems, test features, yeah, it's a very good one. So if we like introducing a new product feature, we could see like what customers talking about this feature and what could be improved accordingly. Nice. Okay, I think this was a good exercise. Thank you for everyone who gave the input. Now, if we gonna cover like text analytics nowadays, what is text analytics? Text analytics could be described as the process of transforming our unstructured data to uncover meaningful information, patterns, and insights. Unstructured data in our context is the customer reviews that we're gonna work on. It leverages various techniques, which some of were mentioned in the previous slide, which are like generative AI, like utilizing LLMs, or natural language processing, whether we are talking about topic modeling or simply working with small language model. According to IBM, unstructured data comprises over 80% of enterprise data. Unstructured data, we know that it can mean text, audio, and image, but of course text would comprise a good proportion of this amount. What are the forms of text data that we can work with? Text data can come from survey responses. We send our customers some surveys. They could answer what went well, what could be improved. We could work with that. We could also look into Trustpilot. So if we send customized links to customers where they can submit or post comments on Trustpilot platforms, we could use or scrape the reviews from Trustpilot and work on them. Notes from call center, particular product feedback from customers, or simply social media posts from LinkedIn, Instagram, or Twitter. The techniques of text analytics, I think most of these were mentioned in the previous slide. Sentiment analysis, where we classify reviews into various topics, such as positive, neutral, or negative. Topic modeling, which we're going to talk about today, which can help us identify recurrent themes from the reviews in an unsupervised approach. Named anti-recognition, we also spoke about it, is simply looking into the reviews and try to take out like what customers are talking about, like whether location, product name, monetary value, etc. Text classification, where we have like set of reviews already classified into various business themes, which we can also use this labeled data set in order to classify future incoming data. Information retrieval is, I think this is also very relevant these days, where we have like set of documents, and whether PDF documents, and we try to extract information from these documents, whether through using RAG, LLM, or simple character recognition techniques. Summarization, also like one of the prominent text analytics techniques, where if we have long documents, in order to automate the process of reviewing these documents, we could have a summarization model which summarizes into very concise and brief summaries. Yes. So With text analytics, definitely we can boost customer experience. How we can boost customer experience? First, the two key benefits that we can look at is we can have data-driven customer understanding and insights. So with this tool in place, we can reveal customer needs, preferences, trends, and pain points, so we can make decisions or data-driven decisions accordingly. The second benefit is definitely we could have like efficient data processing, whether we're having like a person who goes over these reviews in a manual fashion. We could have it like more efficient and automated way, so we could save time and resources. The KPIs that we can look at while doing this project is definitely increasing customer happiness and sentiment, which was mentioned by you. We could look into churn reduction, or keeping customers with us and decreasing customer attrition rate. And last but not least, we could also look into what amount of revenues we could generate if we are like hearing or like giving attention to customer voice, such as if the customer is talking about a product relevant to the product that they purchased before. So we could think of like offering customers cross-selling opportunities or upselling opportunities in order like to generate more revenue from loyalty programs, rewards, or incentives. I think this is very, very, very comprehensive slide. I think for any data scientist or data analyst working on project related to customer reviews, and based on my experience, these are the phases or the stages that everyone should think about it. So the first stage is definitely the data extraction phase. During the data extraction phase, we should look into the data sources that we will get these reviews from. Are we talking about Trustpilot, where we're gonna like get the reviews from Trustpilot and conduct text analysis on them? Are we talking about customer feedback forms, surveys we are sent to customers, or simply we are talking about social media posts? After we determine the source of the data that we're gonna work with, the second step here is to see how we can collect this data. If we are talking about Trustpilot, are we gonna set up a process which scrapes these reviews using the Trustpilot API, use scraping packages such as Selenium, etc. Or if simply the data is hosted in our database, so we could simply use SQL query to extract this data and conduct the analysis. This is some of the questions that we have to keep in mind. And after we extract this data, definitely we should do some data cleaning in order to make it ready for the data science modeling. After we extract the data, I think an important step is to determine what will be our business KPI, or the key performance indicator that we have to monitor, or like we have to look after implementing the project. This is the business goal of the project, which simply comes from non-technical stakeholders, whether from finance or marketing or the product team. And then we identify these KPI measures that will help us to measure the impact derived from the project, whether we are looking into increasing sentiment, net promoter score, churn rate, etc. After we determine the business KPI, definitely we have to think about what AI technique we're gonna use. If we are using topic modeling, so what Python package can help us to do so? Are we talking about NLTK, Spacey, GenSim, scikit-learn, etc.? Simply, if also like we're talking about text classification, we can think of HuggingFace, or nowadays we can think of LLMs. So in this step, we simply just determine what AI technique are we using, whether topic modeling, classification, or summarization. And based on the technique that we are using, we have to choose proper library or package from Python or whatever programming language we are using in order to help us implement the technique. So after we determine the technique, we look into to build a solution. If we are talking about topic modeling, we extract relevant and recurrent topics. And if we're talking about text classification, we simply classify the reviews into predefined categories that we already know about. After that, after we build the solution, definitely we need to look into validate the output that we have from the model. And with validating the output, I would say we have to do two things. The first thing is simply look into data science performance measures, whether we are talking about accuracy, recall, if we're talking about text classification, or if we're talking about topic modeling, we look into perplexity, which shows us how well the model is predicting or is recognizing the underlying patterns in the text or in the reviews. And the second validation step that we definitely have to do, we shouldn't rely only on the performance measures. We should involve domain experts to review the results for us and make sure that the model is generating like reasonable and accurate predictions or categorization. After we do our validation, definitely we need to go into deployment. Deployment, we need to productionize the model, refactoring our code, like building unit tests before taking the model into production, and we have to make decisions whether we need like to deploy the model in batch versus real time. So are we gonna like take all the historical reviews and generate topics for them, or are we gonna like generate the topics on real time as we receive the customer review? I think it's not even like real time. We can think of it near real time. So like when we receive the review, we generate the topic for this review. And after we do the deployment, definitely we need to think of visualization, how we can bring this data to end users using business intelligence platforms such as Tableau or Microsoft Power BI through building like interactive dashboards. And I can't emphasize much into interactive dashboards because this is the end product that the stakeholders are gonna interact with. So the better the interactive dashboard or the more easy and seamless for them to navigate, the more the model output will be used by them. Last but not least, I think the last step is performance monitoring. So we need to continue to monitor the track of the performance of the model, whether we are looking into the performance measures, and think of how we can evaluate the impact of the insights on business metrics. So if we build this model and we have it in place, we can monitor how the sentiment has increased over time to see how successful the project is. Yep, so now we're gonna talk about the topic modeling. So the topic modeling is a way for us to uncover business themes in the customer reviews. So it's an unsupervised learning technique because here we don't know what categories or what topics customers are talking about. We just have like this bunch of reviews, and our goal from this topic modeling is to try to identify these underlying themes. So for example, if we think of like a customer with a utility company who says like, for example, the tariff is expensive, while another one says the energy package is unaffordable. Knowing that they have used two different words, which is expensive or unaffordable, the topic modeling should infer that they are talking about the tariff, and these two reviews should be categorized under tariff price. This is like in a nutshell what we are trying to achieve here. In order to do topic modeling, I did summarize here like the 6 steps that we have to go through. The first step is definitely text preprocessing. So we can think of more of data cleaning plus text preprocessing is like preparing the data into proper format before giving it to the topic modeling algorithm, which is LDA in our case. Text preprocessing might include like removing stop words, lowering the text, removing emojis. So removing like the unnecessary words or like characters in the text, which might not add value to the model, in order to make the process more seamless. After we do the text preprocessing, we do feature engineering. Feature engineering is simply, we can think of it like the models will not understand words, so we need to transform these words into numeric embeddings or numbers, and this is what we are aiming to achieve in feature engineering step using methods which we're gonna talk about, such as bag of words or TF-IDF. After we do the feature engineering, we go into step which is model training. We just like load the model from whatever package we are using, and then we train it on our cleaned, processed, and engineered reviews. After we do model training, we extract the topics. We see what topics are being discussed in the reviews, and here should be like some experimentation for us to know how many models, how many topics we should look after. So we should do like experimentation with trial and errors. For example, if we extract 5 topics, how coherent are the topics? We could do with 6, 7, 8, and then we could like specify or like select the best number of topics which solves our problem in this scenario. After we extract the topics, definitely we visualize the topics to see within each topic what are the recurrent words in order to affirm the category name. And then after the topic visualization, we need to do topics validation. And in this stage, I would say here, like you should have like a domain expert or someone from the business in order to say, for example, if we have this bunch of words grouped together, this is the relevant theme that will be tagged with. A slide about text processing in particular. So what are the needed steps for us to perform before doing the LDA training? Definitely, we have to remove stop words. Remove words containing numbers and special characters. And to do this, we simply can use the Python method from regex, which is re.sub, which is simply substitute these characters with space, for example. So this is to remove the words containing numbers and characters. We use re.sub. And then, other than removing words containing numbers, we should break the text into tokens. And because the reviews are like a bunch of words, we have to break these reviews into tokens. And for this, we can use a Python method called word tokenize from NLTK, which natural language toolkit library, Python library, which simply like load this word tokenize and then perform it in the reviews. After we tokenize, we do lemmatize. And lemmatize is simply obtaining the word origin from the context. So, for example, if we're talking about running, we get the word origin of running, which is run. Better, it's good. It's worth noting that there are two methods here. There's lemmatize and stem. But lemmatize is simply helps us to generate the word origin within the context of the text. After we do lemmatization, we remove stop words. Stop words, we can think of it like words which doesn't bring value to the text, whether we're talking about prepositions or pronouns. And we also use NLTK for that, which helps us to load the stop words list and then remove it from the text. We can also remove punctuations. And to remove punctuations, we use the string Python library. And last but not least, we lower the text and we remove short words, which also doesn't add value for us. We're gonna see this in code as well in a bit. So after we do the text processing, we definitely need to do feature engineering. Feature engineering, as I said, we can think of text representation approaches, which are transforming the tokens into numeric word embeddings, which can be understood by the model. And for this, we could think of two approaches here. The first one is called document to bag of words embeddings. And what this approach does in particular is like it uses a dictionary of all unique words, which is called vocabulary in this case. And based on this dictionary of words or dictionary of corpus, we could count the number of occurrences of each word appears in a document. So if we're talking about review and the customer is talking about tariff, so we map tariff into the corpus, so we get what's the number or the numeric embedding of tariff in the corpus, and then we count how many times the word tariff appear in the reviews. So at the end of this step, you can think of generating list of tuples of words, and each word is represented as numeric embedding, so as tariff, and then how many times the word tariff appears in this text. It's worth noting that document to bag of words, it has like a limitation, and the limitation it ignores word order and context, so it doesn't look into like at what stage the word tariff appears in the text, and why the customer why the customer is talking about the tariff in this review. So it ignores word order and context. The second approach for doing word embeddings is called TF-IDF, which is term frequency inverse document frequency embeddings. It's also very popular. And we can break TF-IDF into two components. The first component is called term frequency. And term frequency, it simply measures how frequently a word appears in a document. Same as document, so same as document to bag of words. So if we're talking about word package, so how many times the word package appears in this document. So this is the first component, which is term frequency. But the other component of TF-IDF, it's called inverse document frequency, or IDF. And in this component, we measure how important a word is by accounting for its frequency across the entire corpus. So you can think of the corpus as the collection of reviews, and the document is each review separately. So the first component is looking for the word package in each review, and the IDF is looking for the word package in the whole bunch of reviews that we have. And by doing that, we could look into how important the word package in each review separately. But because we are doing the inverse in the second step, we decrease the importance of the word package because it appears many times. So it's like if the word appearing many times, which is more frequent in the whole bunch of reviews, this gives us more important. I think package might not be the relevant example here, but if we look, for example, words which are being said regularly by customers, such as great and amazing, which will appear in a huge proportion of the reviews. So we can think of reducing the importance of these words while focusing on words which are not recurrent or highly given by the customers, but it's still important to our analysis. This is for the TF-IDF. We're going to also see it in action, in code. And then it's also worth mentioning that TF-IDF has the same limitation as document to bag of words, which it ignores word order and semantic meaning. So LDA, by the way, I'm gonna post the slides on the Slack group, and I already I gave the link for the page for the paper of LDA, but LDA is one of the most popular topic modeling algorithms that is used by industry, and it's introduced in 2003. And what LDA does, it aims at taking this bunch of reviews that we worked on, like we cleaned, we processed, we generated text embeddings using feature engineering techniques, and then it tries to learn the topic distributions that best explain the content of these entire documents. The entire documents constitute the corpus for us. It's good to know that LDA is available within 2 Python libraries, which are gensim and scikit-learn. You might question, when should we use gensim versus scikit-learn? I would say that gensim is better to use when you have huge data sets, because it does well in performance and scalability, whereas scikit-learn LDA, it's better to use when you have small to medium data sets. So LDA, it applies probabilistic modeling approach. So first of all, it identifies the topic distributions across these documents. After it identifies the topic distributions, then it assigns a word distribution to each topic. And after it assigns the word distribution to each topic, then it creates the topics and the frequency of each topic per document. So we're gonna see it also in the code, but at the end, you would have the topics which describes these documents or these reviews. And then for each topic, you have words which describes these topics. For each word, you have a probability that it relates to topic X versus Y versus Z. The limitations of LDA, in my perspective, It ignores the order and the context of words within documents because we are simply here looking for the occurrences of words. We are not taking context into consideration. And the second limitation is like sometimes you could generate topics which cannot be interpreted easily. So it's difficult for us to interpret meaningfully the output of LDA. And here it becomes like you need like a business judgment or domain expert to help transfer or transform the LDA output into relevant categories that we should look into. Nice. So we're gonna look into the topic modeling application. I think I already posted the notebooks in GitHub, but we're gonna use Google Colab, and if you are gonna use it locally, that's fine, or you can apply it later. So we're gonna look into the customer reviews topic modeling notebook. And it's worth noting that the data set that we're gonna work with today, so I did this project on my company's data, but for confidentiality, I cannot use it here, but we're gonna apply this exercise on data set for British Airways, which is a public data set available on Kaggle. And we just like gonna download the data set and do the topic modeling and the HuggingFace fine-tuning approach here. So what does this notebook do? It simply takes the bunch of reviews from British Airways, taken from Kaggle, and then we're gonna first apply LDA from Jensen with bag of words in order to know the topics or to learn the topics. And the second approach that we're gonna use is from scikit-learn and TIFI-IDF. So I think just like I want to give you an insight how to do it with Jensen versus scikit-learn, and to use bag of words versus TIFI-IDF. The first cell is simply like just like importing standard libraries, pandas, regex, string. Then we're gonna import the NLP libraries, which is NLTK, and from NLTK we're gonna use stop words to remove the stop words which are not useful in the text. We're gonna look into word net limitizer, which breaks the words into their origin based on the context, and then word tokenize, which is method to break the text into tokens. And then we're gonna import the sklearn libraries, the LDA from sklearn, and then we're gonna use the TIFI-IDF vectorizer to help us do the feature engineering for the text. And after we do the scikit-learn libraries, we look into the Jensen libraries. And we're gonna also use the visualization library called word cloud to help us to create word clouds of the topics generated from the LDA. And here, just like, so we load the stop words from LTK, and then let's say you need like to extend this list or this set of stop words. So you can simply think of words that are not relevant in the context of our reviews and simply remove it. So we take the stop words, and in this case, we're gonna remove these words, like just an example for you, that is not relevant. So we can remove like British, Airway, company, service, Heathrow, hour, minute. And this list could be extended based on the context of data that you are working with. So you can extend the stop words list on words which you think it's not important for this exercise. So we load this, I think it's working, nice. And then we load the data. And what does this function do? Simply it loads the data from our local machine, and then because like it's big, we just like sample 20% of the data. Here, if we choose file, so here we're gonna use the reviews data. Reviews data is the set of reviews which were taken from Kaggle in its original format, which is unlabeled data. So we load the reviews data. I think it's loading. And then the second step, if you remember from the slide, we need to do data preprocessing. By data preprocessing, we're just going to have a function which prepares the text data into the LDA training, and there are a set of steps that we have to follow here. So first of all, we remove the text in brackets. If there's text in brackets, you remove the words which contain numbers. You tokenize using the word tokenize method. Then you limitize. You break the text into its original format. You remove stop words, and then you remove punctuations and short words. So we use regex to remove text in square brackets here. Then we remove special characters such as emojis, also using regex. We tokenize the text using word tokenize. And then we initialize the word net limitizer class in order to limitize the text or to limitize the tokens. It's worth noting that we do tokenizing and then we apply limitization. And at the end, we just like take the words which is not available or which is not listed in stop words. So just like remove stop words in the step, and we remove punctuations, and we take words or tokens which is greater than 5 characters. I think if we print this here, you could see how each review is being broken into tokens. So after we do the text preprocessing, the next thing that we're gonna do, we're gonna apply LDA using Gensim, from Gensim. And within LDA, we're gonna apply the bag of words, the approach that we spoke about in the slides, which simply map the words into the vocabulary or the corpus of vocabulary corpus, and then just like count the occurrences of this particular word in the slide in the reviews that we have. So first of all, we call the corpora dictionary, and we apply it on our reviews column, and then we generate the occurrences of this particular word, and then we initialize the LDA bag of words model using from Gensim, gensim.models.lda.lda model, and then we give it the corpus, and then we give it the words which are matching with this corpus, such as the word and its occurrences. And then we define the number of topics. And this is what I was talking about earlier. So here I'm trying with 6, but we could also try with 7, 8, 10, 5. It depends. It depends how many topics you would like to generate. So you generate the topics and you see how these topics generate or like reveal the actual themes in your business. And we could also look into like performance measures such as perplexity or coherence to tell you like how this number of topics is doing in terms of performance. So just like doing, you can think of it like hyperparameter tuning in order to know what's the optimal number of topics which we should use. And then if we do this, and then we apply it here, so you could see now, because I said I wanted 6 topics, so we could see the 6 topics here. And within each topics, what are the words which describe this topic? And if we wanted to do it in a more visualized way, we could, as I said, we could use word cloud. And we simply visualize the Gensim and bag of words topics using a bag of words. And to do the word cloud, we just need to give it the topics which were generated by the model and the feature names, which are the words that we have. So here we could see what are the topics which describe in our collection of reviews. You could see, for example, some of the topics are talking about breakfast, which is around entertainment and food, I think, or simply food. Others is talking about boarding. Other set of reviews talking about entertainment separately. Then another topic is talking about returns, like flight returns. A topic talking about lunch, and topic talking about boarding and lounge as well. So what you could see here, so it's not like an excellent differentiation of topics, because I will still see that some words appear on topic 2 and topic 6, because topic 2 is talking about boarding and topic 6 is talking about boarding and lounge as well. So the differentiation or the distinct, to generate distinct topics might not be a straightforward exercise. That's why you have to do trial and error with different number of topics, see what the topics are generated, and then decide if we want to keep this number of topics or try different one. The second, the topics from LDA and back of words could be like summarized here. We could have launch, we could have crew experience, we could have flight returns and refunds. Other topic could be luggage, boarding, and the last one could be departure and flight times. The other topic modeling approach that we also spoke about is using TF-IDF, or term frequency inverse document frequency, and we're gonna apply it with LDA from scikit-learn. So the previous one was LDA with GenSim. Now we're gonna talk about LDA from scikit-learn. Similar initiation as before. You initialize the feature engineering method, which is TF-IDF vectorizer in this case, and then you give it the reviews tokenized that we had, and then we transform it here. We fit the TF-IDF vectorizer on our text data, and then we run the LDA, but we give it now the TF-IDF featured words that we have, and we are also specifying that we need like six topics. Number of components helps us to determine the topics that we want, or number of topics, and then we're gonna print out the top 10 words within each topic. So if we do that, here we can see what are the topics and what are the words which represent these topics. We could also apply visualization from word cloud. And here we could see also one topic talking about launch, other topic talking about booking, the third topic is talking about departures, the fourth topic is talking about luggage, the fifth topic is talking about flight returns, and the last one is talking about baggage and boarding. So, So at the end of the day, we could think that you have topic modeling output from two different models, one LDA from GenSim and one LDA from scikit-learn. If you are sufficient or convinced with the modeling, with the output of topics that you receive, you could simply train your model, productionize it, and let it generate the topics for the remaining reviews, or like the future reviews, incoming reviews. Or you could simply, and this is where we're gonna move to the second part of the presentation, where we're gonna talk about SetFit. You can use this like as stepping stone for us to learn what are the topics revealed, or what are the topics discussed. In our scenario, it could be boarding and crew experience, entertainment and food, cabin comfort and baggage, lounge experience, bookings and flights. And then we can use these topics in order to label a small data set and fine-tune the SetFit model, which we're gonna discuss in the second step. But in order to know this final list of topics, I think it needs some business judgment. Now we are talking about like simple scenario, or a simple data set from British Airways reviews. But I think sometimes, and with some companies and industries, the reviews might be more complex, or like if we are doing topic modeling on documents. So here you need like a subject matter expert or domain expert to help you like to know what each set of words or distribution of words refer as a topic. Nice. So this was the application of the topic modeling exercise. I think what are the key takeaways, which I can summarize here, is we could face a challenge that when we generate the topic modeling output, that that topics are hardly to interpret or to infer, and the more you do like effective data processing and ensure that the data is with high quality, the more like you could get like a good output from the LDA modeling. So if you have high levels of noise in the data, which I think it might be the case in most data science projects, is that you could hinder the ability to generate accurate and distinct topic identification. The second key takeaway from here is like there should be business judgment here, or like domain expert, to help transform the cluster of words into meaningful contextual themes. And this requires like some human insight and business understanding to ensure relevance and applicability. And as I said earlier, in my situation, this topic modeling was a good step for me to understand the topics discussed, and we could use these topics, or like topics discussed from the generated from the topic modeling, in order to move to the second step of the project, which is using SetFit. And using the topics generated, we could label a small data set and then do the text classification using HuggingFace SetFit method. Nice. So this takes us to talk about the SetFit method, which is a method introduced by HuggingFace in 2022. I also attached the paper provided by HuggingFace in the slides if someone would like to go over it. But what does SetFit do? It applies few-shot learning. And with few-shot learning, it's simply giving the language model, or the sentence transformer model in this case, we give it a few examples of the target task. By giving it these few examples of the target task, we are helping the language model learns what success looks like. So if we're talking about the reviews with categories refunds, boarding, lunch, so we could give the model a good or high accurate labeled examples related for these categories, and we don't need a huge labeled data set, because according to the paper, we could only use 8 to 16 labeled data points per class. So if you have, for example, talking about 6 classes or 6 categories, you could only give the language model 6 labeled examples per class, and then you fine-tune the sentence transformer with these labeled examples, and use it to generate like inference in future unlabeled data. I'm not gonna go in details about the theoretical, or how what's the steps they applied in order to do this sentence transformer fine-tuning, but it's worth noting that they take these labeled examples, this small number of labeled examples, and then they generate sentence embeddings from these set of labeled reviews, and they applied something called contrastive learning, which is mainly used in the image domain, but they apply it on text, and they take each, for example, you think of the review with embeddings, and then you compare it with the nearest review, and then they create a similarity score, and I think they use the cosine similarity. So at the end of the day, you could think of these embedding reviews with similarity scores, and then if you have, for example, a review related to refunds and review related to payments, then you could imagine that the similarity score between these two reviews is going to be high, and it's going to be in the same category. So this is what they did in contrastive learning. So just transform these reviews with embeddings, and then they use the contrastive learning in order to learn the similarity between these reviews. So it's also like it increases the value on the data. So we're only giving it like 8 labeled examples per review category, but the way they're gonna match each review with its nearest review, so it could learn the distribution, or like the structure and the structure and the context of these reviews from the embeddings. So after it does the contrastive learning thingy, the second stage of the SetFit is fairly simple, which simply they have these embeddings, and then they applied a classification hat training, and according to the paper, they simply used logistic regression, which simply learns the label of each embedding, and the labels could be one of the categories that we have. So the key advantage of the SetFit method is definitely it's efficient, because it only requires only 8 to 16 labeled examples per class. This is according to the paper, so you don't need to have or to incur a huge amount of time to do data labeling. You just can do data labeling of a small labeled data set. So if we're talking about text classification with 6 classes or 6 categories, you could have 8 labeled examples per class or per category. So this is why it's efficient, and then it has high performance. So again, according to the paper, I would advise you to go over it. They did several experiments where they applied fine-tuning using the SetFit method and using other language models, larger models such as GPT-3. And then at the end of the experiments, they found that the sentence transformer, the SetFit method in particular, it could generate results faster and similar results to GPT-3. So with less number of parameters, with less labeled examples, it still achieves high performance. And then we don't need, it's prompt-free framework, so we don't need to do prompt engineering to the sentence transformer to tell it what does it do. We just give it the small labeled data set. And it has multilingual support where it can classify text in multiple languages. The fine-tuning SetFit implementation steps. So SetFit is available through the HuggingFace SetFit library. I'm not sure if we can. Let's see if we can go there. So this is the page on the HuggingFace website. So it's available within this library, and within this library, you could use the SetFit model, which is simply its class, which loads the pre-trained sentence transformer that you want, and there are a bunch of sentence transformers that you can use. And then after you choose the sentence transformers or the language model that you want to use, then you use the trainer class, which will handle the fine-tuning process for us. We're also gonna see it in code. And then you need just to input some training arguments, such as number of epochs, batch size, learning rate, etc., in order to guide the fine-tuning process. So the steps to conduct the fine-tuning using SetFit, it starts with data labeling. As I said, you should have small labeled data sets. And by small labeled data sets, again, according to the paper, you could only have 8 to 16 labeled examples by class or category. So after you do this labeling exercise, then you do data preparation, such as remove reviews with null values, or just lowering the text. I would say that here data preparation is not important as the one in topic modeling, because here just taking the reviews. So even if we keep the stop words, it wouldn't make a difference. And then after you do the data preparation, you just do train test split, which is very we all know that when we are training machine learning model or whatever, you need to use some amount of the data for the training and test to do performance measuring. And then you need to do data transformation, because the language models from HuggingFace, they expect the data to be in the dataset format, and you just use the dataset library and transform the pandas data frame that you have into dataset format, which is better for optimization. And then after you do the data transformation, you just perform the fine-tuning, and by performing the fine-tuning, just initiate or load the sentence transformer from HuggingFace, giving it the labeled data that we created in the previous step, and then fine-tune the model. After you fine-tune the model, you definitely need to do model evaluation. By model evaluation, just look into the performance measures such as accuracy, recall, or whatever. Then, after you do model evaluation, you save the model locally. And after you save the model, you could push your model to the HuggingFace interface. We're gonna also see how you do so. And after you save the model to the HuggingFace platform, or you can save it locally as well if your company has some privacy issues and they don't want the fine-tuned model to be available in the HuggingFace model, you just can save it locally or within GitHub or GitLab and then use it to generate inference. So after you do model save, then you use the fine-tuned model to generate inference on incoming text data. To generate inference using SetFit method, using the fine-tuned SetFit model, you simply, as I said, you need to share your fine-tuned model to the HuggingFace. In order to do so, you can use the web interface. You simply save your model locally and then go to the interface and upload your model files there. Or you can use the client API, which is I'm gonna show today. You just take your API token from the HuggingFace account and then push the fine-tuned model to the HuggingFace. After you push your fine-tuned model to HuggingFace, you just can load the model using SetFit model from pre-trained. You give it your model ID. The model ID is the model name in this case. And then after you load the customized fine-tuned model, you use this fine-tuned model to generate predictions on real unseen data points using the .predict method. Last bit here around model evaluation and performance monitoring. So after you train your fine-tuned model, or after you apply the fine-tuning process, you need to look into model training metrics. And these model training metrics, it could be accuracy, recall, precision, or F1 score, depending on the business goal or objective that you have. But also, you can think of having a baseline approach, which helps you to generate categories, and then you compare it with the predictions that you have from the fine-tuned SetFit model. So, to simplify it, the fine-tuned sentence transformer will generate categories for us. These categories, it could be whether boarding, refunds, launch experience, etc. And after you know these categories, or these generated predicted categories by the SetFit model, you could also try to define keywords for each class and category. For example, if we're talking about refunds, we could expect the review to contain words such as refund, money, amount. If we're talking about launch experience, we could expect the review to contain words around launch, business customer, etc. Then you can, after you define these keywords which you expect to be available in the review, you can search for these words or search for the text and in the reviews, and then at the end of the day, you could generate a baseline theme category based on keyword matching. So just using Python libraries such as Fuzzy Wuzzy or regex, we just look for certain words in the review, and then you generate the baseline theme, and then you can compare the baseline theme with the generated theme from the sentence transformer and see if it makes sense. So if the sentence transformer is telling you that this is around refunds, and your simple text matching exercise is telling you this is also around refunds, you could have more confidence that the model is giving you accurate predictions. So you can think of it if you are putting this model into production and moving forward, you just need to generate some confidence that the model is giving accurate and reasonable predictions. And to do so, you just take the output prediction from the model, and then do another text matching exercise aside, and then compare the two categories and see if it makes sense. And the more it matches, the more the matching comparison between the baseline theme and the theme generated by the sentence transformer is like similar to each other, then we could have more confidence that the model is giving good and accurate predictions. Yep, just like to note that the text matching libraries that you can use Fuzzy Wuzzy. We're gonna also see it in the code in a bit. And Fuzzy Wuzzy just like looks into the similarity ratio between the text data and the transformation and the measures needed to transform to required between matching string A and string B. So for example, if we're looking for word refund, and then it looks into the words available in the review and see if we can find refund or similar word to refund in the text. Regex is also another Python library which we can use for text matching, which simply looks, if we are talking about refund, it simply looks for the exact word of refund in the text. Okay, so I think now it's time to go to the hands-on application on fine-tuning SetFit and performance monitoring. And for this, we're gonna use the second notebook, which is customer reviews SetFit. I did run it before, but I think it needs some GPU in order to, especially in order to fine-tune the sentence transformer on the British Airways text data. We need some GPU power. But what we're gonna do, we're gonna fine-tune the sentence transformer like on a very small data set, giving like loaded from the dataset library. So we're gonna do a quick demo of fine-tuning using sample data from datasets library, and then we're gonna perform inference on a fine-tuned model, which I already pushed to HuggingFace, but I also gonna show you how to push your model. And then we're gonna do the baseline evaluation mechanism that I spoke about using Regex and Fuzzy Wuzzy. So we just need to pip install. So we're gonna just install the transformers package from HuggingFace, then the SetFit, which we're gonna handle the fine-tuning of the sentence transformer model, Fuzzy Wuzzy, which we're gonna help us to conduct the text matching exercise for similar words, and Lugoro, which will help us to print some messages in the way. I think this might take some time. But then we import the libraries and packages that we're gonna use, which is Fuzzy Wuzzy, Lugoro, train test split in order to do the train test split at later stage. We're gonna use the notebook login from HuggingFace Hub, and this will help us to push our fine-tuned model to the hub. And in order to push the fine-tuned model to the hub, we're gonna see it in a bit. You're gonna create, of course, an account in HuggingFace, and then grab the API token from HuggingFace and put it in your notebook in order to push the fine-tuned model there. It's still running. Then after you import the packages and the libraries, you just need to set main variables. And these main variables simply, you just need to select your training model. And if you go to HuggingFace, I think you can choose from different sentence transformers models. So you can have different sentence transformers that you can choose from. But in my case, I'm just like, I selected this sentence transformers model. You can just like also try it with different ones. And then the test size, in order to do the train test, you can select it 10, 15, 20, as much as you want. And then you just input some main variables, some training arguments. And the training arguments could be the batch size and the number of epochs. Now, batch size, it's simply the number of samples that should be passed through the model at once before updating the model parameters. And the number of epochs is the number of complete training steps that we need to apply during the fine-tuning process. So after we do this, then we do the data preparation for fine-tuning. Here, just simply, we are taking the labeled reviews. So I did some data labeling for this. So as we explored in the topic modeling part, these were the 6 topics that I inferred from the topic modeling exercise. And then what I did is just like I did create a labeling data set around these topics. So I did like 8 labeled examples for each of these topics around this: booking and refunds, boarding, lunch, cabin comfort, entertainment and food, and flights and departures. So here, if we just like load, there's a data which is called labeled reviews, which, as I said, it's like only 8 labeled examples per class. And then, just like mentioned here, it's a good one. I'm just mapping the categories into numbers because, yeah, as we know that the model will not understand categories. So just like giving it as numeric numbers, like flight and departures to be called 1, entertainment to be called 2. And here you can also like use other approaches, such as categorical encoding from scikit-learn, which can do this like in a more seamless fashion. So yeah, we loaded the data set. And then this exercise here simply to do a split train test. So we did specify that we want 85% used for training and 15% used for test. And then you do the data transformation. The data transformation is simply to transform the data into a format which is accepted by the language models in transformers, which is like using the data set. So just like using data set from pandas, and then you transform the train data and the validation data into data set format. And then the fun begins, which is to apply the fine-tuning on the labeled customers reviews data set. And in this exercise, or in this step, you just, this function would take the model, it will load the model from the HuggingFace library, and the model is the model we initiate in the beginning, which is the sentence transformers model. And as I said, you could choose whatever sentence transformer model you want and just do some testing around it. And then using the trainer class, you just give it the model, you give it the training arguments we specified in the beginning, you give it the train data, the validation data, and then you initiate or you start the training or the fine-tuning job using trainer.train, and then save the model locally. So if you want to save it locally, you save it like trainer.model.save.pretrained, and then you evaluate the model using trainer.evaluate, simply like generating the accuracy matrix of this fine-tuned model, and this fine-tuned model will evaluate based on the test set that we give it to him. So train to train, to do the fine-tuning, and the test set to conduct the evaluation. Nice. So yep, I'm not gonna run this cell here because, yeah, as I said, it needs some GPU power. But feel free to try it out. This fine-tuning would be applied on the customers' reviews of bridge arrays. But here I'm gonna just do another like a quick demo on fine-tuning using another data set, which is loaded from HuggingFace dataset library. And if you see here, I'm just gonna load the train and validation data sets for a quick demo. And then I'm just gonna apply the fine-tuning function here. So here we see that it's conducting the fine-tuning, loading the model from HuggingFace, and then we are outputting the model and the matrix. You could see the optimization steps. These are the training arguments we set in the beginning, batch size 16, number of epochs 1. And of course, you need to increase this if you want to to achieve better results. You should have more number of epochs, but also you should try with different batch sizes, like 16, 8, 32. And we could see that the accuracy of this model is 83%. It's worth noting that when I conducted this exercise, or when I applied the SetFit on my company's data, I was able to achieve 78%. And then, so after we completed the fine-tuning, you need to push the model to the hub in order to be used in the future inference. And to do this, you need to go to HuggingFace first here. And in your account, I'm not going to take it here, but in your account, you go to settings. And in the settings, you can go to access tokens. And then you generate, first of all, you need to generate a token. You just name it, and then you generate the token. And then you take this token from here, you copy this token, and then you paste the token in the notebook here in order to, I think it's gonna work. No. Yep. And then you take the token, and then after you give it the token, then you push your fine-tuned model to the hub. You just give the repository name, and then the name of the model. For example, we are calling it fine-tuned SetFit PyData demo. And then you push it. I didn't give it the proper API. But I think here, if we go to models, yep. If you see my this is my homepage in HuggingFace, and this is the PyData fine-tuned SetFit PyData demo, which I pushed it, I think, 2 hours ago. And then this is the fine-tuned customer reviews model, which I also completed before. And then now, what we're gonna do, we're gonna use, this is I think this model here, the customer reviews SetFit model, this is the output of the fine-tuning process on the customer reviews itself. So now I think we're gonna use this model to generate inference on customer reviews. If we go back here, so simply this didn't run well because I didn't reveal my API token and paste it here. But yeah, if you paste the correct API token, then you can complete this exercise. Then, now I'm gonna load sample reviews data, which doesn't have reviews. And then I'm gonna use this model here, which was fine-tuned before. And I'm gonna use it to generate inference. So I'm just gonna take the reviews data. And then I'm gonna generate inference. So to generate inference, it's pretty easy, I think. You just load your fine-tuned model here. So this is my fine-tuned model. Sultan, our customer reviews SetFit, this is it. You just take the model name. You take the model name, and then you load your model using the SetFit from pre-trained. And then you give the model the reviews that you want. You give it in terms of list. And then you do the predict, but before you do the predict, you do the predict here. So you give it list of reviews and you ask the model to predict. And then after it predicts, the model will give us the numeric labels, which is range from 1 to 6. And I simply do reverse mapping. So if it's predicted number 1, I know this is flight and departures. If it's predicted number 6, I know this is bookings and refunds. And as I said earlier, you could simply automate this process using categorical encoding from scikit-learn. And then if we do run this, then I run this. So I'm loading the fine-tuned model from HuggingFace, and I'm performing predictions. And then if I print out the F predictions, you could see for each review, I have the predicted numeric label, and I have the theme category which associated with this prediction. Last but not least, I think here is another example, is we give it like sample of reviews here. For example, the first one is about entertainment, refund, booking, etc. And then I just ask the model to predict on these. And you could see, where is it? Okay, I think it's not running well, but I think what should this give us? It gives me for each review here given, it should give me like this is related to entertainment, this is related to refunds. Okay, and then the last part of this notebook is simply to do baseline evaluation mechanism that we spoke about using fuzzy wuzzy and regex. And simply here, I'm using from this data frame, I'm saying if the predicted theme is around entertainment and food, I would expect the review to include words related to food and entertainment. And then if the review is around flights and departures, I would expect the review to include some words related to this category, and just I'm doing text matching to find these words. So to do this, I just, here, let me run this. So I'm gonna do this function, just do the keyword search in the text review, and then I compare the baseline themes, which are the results from the text matching exercise, versus the predictions from the SetFit method. And here I identify the words which I expect to have within each review. So for example, if I'm talking about boarding, I expect the review to include words around crew, boarding, attendance. If the review is around entertainment, I would expect the review to include words include media, Wi-Fi, screen, headphone, etc. If the review is around launch, I would expect the review to include launch, service, offerings, business. So then just like I'm doing text matching to see for each category of reviews, are these words available or present, yes or no? Run this. Yep, and what does this telling me here? So I'm doing the comparison between the predictions from the model and from the baseline themes, and I would compare the two, and I would say the comparison result between the fine-tuned model predictions and the established themes based on keywords is 89% true. So 89% of the reviews have predicted categories from the model, which matches baseline categories from keywords matching. I think the bottom line from this is just like to have some monitoring mechanism going in place when you put this model in production, which gives you some assurance how logical or how reasonable the predictions from the models are. Yep, this takes us to the end of the notebook. I think, yep, just like my key takeaways from the SetFit exercise, it's just like you need to implement evaluation performance mechanism, because you cannot trust the predictions from the model for 100% or blindly. Just think of evaluation mechanism which helps us compare the baseline predictions versus the advanced model output. And the second one is definitely, you could explore large language models nowadays, just like have LLM, such as Mistral AI or ChatGPT, and do some prompt engineering or few-shot learning capabilities in order to do text classification with less technical complexity and overhead as well. And this takes us to the end of the tutorial. Thank you.